Okay, so as I said, there is two ways of changing the value in a memory location. We can either use the address to change the value if we know where the memory location is, so the address, or we can use the variable name associated to that memory location to change the value. So this is what we're doing here. Here we use the variable name associated to the memory location to change its value, or we use the address to change the value of that memory location. I want you to notice the start sign. This is very important because without a start sign, you're telling the compiler you want to change the value stored inside the variable address. So this will not change the value stored in the address, but it will change the value stored in the memory location labeled or named address. So when you do something like address equal 183, it will change the value here. But if you want to change the address, the value of the how to say, if you want to change the value um, stored in the address represented by the value stored in this variable, you have to add a start sign. So by saying start, then the variable name, then 183, it will tell the compiler, hey, compiler, I want you to look in the value of the memory location and changes to 183. So which refer to what? It will refer to it. The compiler would say, okay, here we have the address 655. Now you're telling me to look for the memory locations uh, which has the same number, to look for the memory location 655. Okay, the compiler go into the memory and look for the address 655. And once it knows the memory location, it will now go to the value and change it to 183. So this is how the start sign work. So knowing that, we can only say, since when you know the address of a memory location, you can almost do whatever you want with it. I'm going to show you some examples. So now we're starting the demo section. Let's do some practice. The first thing, let's declare a function. I'm going to call it the function, oh, sorry. It will be a function, void, then it will be like update value to 100. So I'll say address. The parameter will be integer. The parameter will be an address and a memory address. So let's be more explicit. Memory address. Memory address. Okay. Let's I'm going to call it update value from address. And let's create another function, update value from variable. And we'll see the difference between these two. we're not seeing the whole screen. So I'm going to delete this one first, then we continue next. Okay, so this function called update value from address will take up the address of an integer memory location. So we're going to say the memory address we want to change the value to something like 100. Do not forget to add the start sign so the compiler will know that you want to change the value represented by the address instead of the value inside the variable. So next, let's declare a variable called my weight. The weight is something like 18. So we display the weight before so here we have the weight, and the weight we display it using that notation. Oh, sorry. And here we're going to display the weight after calling the update value from address. So this will be the after weight. This will be the before weight. And in between those two, we're going to call the update value address. And we pass in the address of the memory location named my weight. So the memory location name is the variable name. Great. So let's compile this code and see what it does. GCC main, the compile code, then the output, we'll call it main, and see what's happened. Yeah, something happened. Before we call the update value address, the value of the memory location named my weight was 89. But after we call the update value from address, the new value is 100. So what does this function, the function update value, how the function update value from address did that? Because it knows the address of the memory location. So it can directly access the memory location and change its value. So this is the power of pointers. That's why when you have a variables or something, you can, so you want to change, you cannot, for example, only values are passed from function to functions. So if you want another function to be able to change the variables from a color function, you'd have to pass the address instead of the value because the value does not represent the address. So now the called function will directly access the memory location and do what it should do. So this is one example. This is one example using the address to change the value of a memory location. Do you have questions? If any questions?
Yes, please. Please, can you go over the using the address to change the value again?
Okay, using the address to change the value again.
Yeah.
Okay, so I'm going to declare a variable called a. So when you declare a variable, a memory location will be created, and a memory location will be created, and the variable a represents that memory location. Uh, oh, sorry, I'm going to change the name. I'm going to call it age. So the variable age will represent a memory location. So this is what we have here. Any memory location have first an address and has also a value. For the age, we have the address 655 and its value is 10. So this is how what a variable represents. It represents a memory location, and a memory location has an address and a value. We can either use the name of the variable to change the value in the memory location, or if we know the address, we can directly use the address to change the value. So there is two ways of changing the value in a memory location, either by using the variable name or by using the address used to access that memory location. So here we have age that represents a memory location. We can declare a variable called address. So this variable is what we call a pointer. Its value, it store values, but not integer values only, but the address of the memory location of other integers data. So we can say something like address is equal to the address of A by using the ampersand. The ampersand notation will tell the compiler, instead of assigning the value, I want you to get the address of the memory location represented by the variable age, and it will assign it to the variable named address. Do not forget that the data type of the variable address is the addresses of integer data. So it's uh, it's a variable like all other variables, only data types change. Now next, if you want to change the value of a memory location, if you want to change the value of a memory location, you can either use the variable associated to that memory location. For example, age. I can say 100. We want to assign 180 to the memory location represented by the variable age. Or we can directly say, hey, compiler, we want you to use the address, then get access to the value of that address and change it to something else like 180. This notation and this one have the same effect, but we used different means to do the same thing, which is changing the value of a memory location. So basically, that's it. I hope you understand.
Yes, please.
Okay.
Yes, perfectly understood now.
Okay.
Thank you.
Someone asked that what is the difference between start um, like that and the thing with ampersand. So this is notation. It depends what you want to tell the compiler. When you say ampersand, the name of a variable, you're telling the compiler, I want the address of the memory location. But when you you type in start the asterisk and the name of the variable, oh, sorry, and the name of the variable, you're telling the compiler if there is, for example, let's say the variable address is, the value is like something like that. It's not a correct notation, but for you guys to understand, let's say we have an address at, let's choose a smaller number, a memory location 1003. And we're going here, this notation tells the compiler, hey, compiler, I want you to go to to look for the memory location which has the address 1003 and change its value to 180. So what the computer will do, it will go through the memory like that. It will go through, it will look for one address 1003. It find the address, then change the value. So by typing something like that, this is basically what we're telling the computer to do. We're telling him to look for the address location and then change the value. So we have to use the start sign in order to to do this kind of operation. So it's just a syntax of the C programming language. Either you want to access the address or you want to change the value stored in that address. But if you want also to display the value of an ad, for example, you can say um, age is equal to plus 10. This is the same as typing something like age plus 10. Here we're using the address. We tell the compiler, I want you to look for the address, then add 10 to the value and assign it to age. But here we're using something more direct. We're telling the compiler, I want you to look for the memory location which has the name age and add the value 10 and assign it again to age. So it's telling the same things, but we're writing it differently. Great. So I hope that answered the question. Now let's move on the next things. Why these memory location stuffs, addresses, all these kind of stuffs? Why? Uh, there are things we call arrays or strings. Um, let's start with arrays. Arrays. Let's say we're going to have something like an array of integer. Array of int. The notation is like that. We tell the compiler we want to allocate, we want to have an array of memory locations reserved for our program. So 10 integers. So why do we need those things? For example, let's say you have a table or you have a list of items you want to display or you want to store. You don't want to declare 100 variables in your program. Since all those variables are the same, you can directly create a tables and then store all those variables inside. But instead of saying array, I'm going to change the vocabulary. I'm going to call it table. Yeah. So we have the table that contain let's say array. I don't want to mess up with the vocabulary. So we have an array of integer, an array of integer. And let's fill up this array. So we have something like an I, or what we call the index, and we have the length of the array. The length of the array is 10. We have 10 elements in the array. Next, we're going to loop through the array and assign values. So for index is equal to 0, index lesser than length, then index plus plus. So each element in an array has an index, or the number of its position. So it starts from 0 and to the length minus 1. I'm going to do a Google search. Let's do a search on Google. We're going to see um, what it is. Arrays in C. Let's look for, yes, we have images everywhere. Open the image in a new browser location. So we have these things. So here, this is the representation of an array of size 5. It has 5 elements, but the elements' positions are numbered from 0 to the size minus 1. So instead of saying 1, 2, 3, 4, 5, we start from 0. So 0, 1, 2, 3, 4. This is the particularity of, this is the specificity for the arrays. So when you want to change the elements in an array, you just have to type in the name of the array and the index, then assign a value. Let's say we're going to take each index, then multiply it by 2. So it will be the end 0 times 2, 0 times 1 times 2, 1 times 3 times 2, 9 times 2. I'm going to call this initiating the array. The next step, we're going to display the content of the array, display the elements of the array. So we do the same things. We say from position or from the index 0 to the last position, we want to move. Then we use the printf function to display the value. And what happens is that, yeah, we access each element. So by typing something like array of integer, then braces, then the index, this will tell, hey, I want to access the variable, the first element, the second element of the array, the third element of the array, till the last element of the array. Let's compile this program and see what we get. GCC main.c, then with the option O, we want to name the output file main.x. Great. And let's run the program. Yeah, I forgot to save the file. compiled, GCC, the name of the file, the executable, the name of the output, then the name, um, then we execute the executable. Yes, we have something like that. The first things we filled up the array. So we say from the position 0 to the last element of the array, we want to change the value of each element to the index times 2. So this is the result we got here. After we do the assignment, we display the content of the array. So it says the elements at index 0 value is 0. The element at index 1 is 2 because 1 times 2 is 2. The element at index 2 is 4 because 2 times 2 is 4. Till the element at index 9 is, the value of the element at index 9 is 18 because the last index is the array size minus 1 because the indexes start from 0 instead of 1. We have 18 here, 9 times 2. So this is all about arrays. When you have thousands of variables to declare that store the same kind of data, you don't want to clutter up your program. You just want to declare a, the one variable, and that variable will represent everything. We're going to see an example uh, which is more understandable. I'm going to change this. Let's say we want to save names, uh, or uh, so let's say we want to change names. Sorry for that. So let's say we want to store a list of nodes. So students have nodes. We want to store their nodes. So I'll create an array of nodes. We have 10 students in our class. So we have 20 students, or maybe 100 students. We don't know. That's a big class. We have 100 students and we want to store their node. Every student has a number assigned to him. So the student, oh, I'm going to limit it to 5 because 100 is too much. The student with the number 0, we're going to give him as nodes like something like 25. The student with value 1, we're going to give him a node of 30. And the student of 2, the student on with the at position 2, we give him the node of 28, and so on. So we have that. Going to give him a node of 45, and this one, its node will be 15. So we have the first student, the second student, the first student, and the fourth student, the fifth student. But do not do something like node 5. This will not work because the index 5 does not exist in the array. The index 5 is for the array with size 6 and above, because the index start from 0 to this instead of 1. Next, we're going to display the node of each of these students individually. node of student 0 is, we display the nodes. So the nodes, we have to name, to take the name of the array, then brackets, square brackets, then the positions of the nodes. Oops. This is 5, I guess. Student 5, 2, 3, 4. And the index also change. We have an array of value. So to access each value, we have to specify the position of the value in the array. This is basically how it works. Let's compile this code, gcc, then main.c. The output file name will be main.exit. Then let's run this program. So we see nodes of student 0 is 25, node of student 1 is 30, and nodes of student 4 is 50. That's great. This is how we use arrays. We can have arrays with different data types, like you can have like floating numbers. Just change the name, the type of the data. So the type of an array will depend on the type of data stored in the array. Great. Now, what is, there is something to know about arrays, very important. Actually,
Hello.
hello, do you have a question?
Yes. Yes, please. Not really a question, but just so that I'm on the right track. So basically, when you want to key in yourself the individual values in an array, you just have to repeat the name of the array and then indicate the index of the element you want to key in, right? If I understand.
Right,
That is
right,
what we just did.
exactly, exactly, that's it.
Okay.
Yeah,
Okay. Thank you.
thank you. So this is it. As Emmanuel explained, it is exactly how it works. You have an array of value, and an array has elements. In order to display the value or access the value of the element, you need to provide a key or the index, sometimes called the positions of the element. Now, the next thing we want to explain is that in reality, these things here is a pointer. It is a pointer to a memory location. Um, how I am going to explain that? Let's say, uh, when you declare an array, what happens in reality? What happens? Here we declared an array of 5 integers. So these integers should have to be stored somewhere in the computer. We're going to draw again. So we're going to change the taxes. Oh, sorry, 605. Um, let's let's change, delete certain some of those. Well, um, great, and that. So an array uh, is in reality a pointer. A variables that represent an array is a pointer. Um, in reality. So how are you going to represent that? Let's add another. Um, um, okay, so here, let's say when you you declare a variable of an array variable of size 5, you're telling the compiler that you want to reserve 5 memory location integer types. So the compiler will go allocate, oh, sorry, the compiler will go and allocate 5 memory location. Let's draw again. I'm going to draw one more thing here. Yeah, that's it. And that one for, oh, what happened? I'm going to make it red. Yeah. We're going to draw another square rectangle, 12 with green, like that. So now we have 5 memory location. 1, 2, 3, 4. 1, 2, 3. We have 1, 2, 3, 4, 5. We did have 5 already. Great. So when you declare an array of 5 integer, the compiler will create a pointer to will allocate 5 memory locations, 5 contiguous memory locations. So it will allocate these 5 contiguous memory blocks. Then it will create um, create a, and it will assign, let's say, it will assign the address of the first memory location to the variable named to the name of the array. I'm going to explain what all this means. Okay, going to make it a little bigger, bold, and we're going to make it bigger like that. Yes. So what the compiler will do, it will allocate 5 memory locations of type integer. All those memory location will be contiguous. But the first memory location address will be assigned to the name of the variables, uh, the variables nodes in our example here, which means you can do something like node, the address node here, +1 to get